All right, on today's episode of Python Papi, we're back inside our smart contracts project. Let's have a look at what we're going to be going over today. And today I did inform you that we're going to be starting a new module. This one is going to be the anti-pattern magic numbers. So let's dive right in. So in this section, we will discuss anti-patterns, more precisely magic numbers. An anti-pattern is basically a bad coding habit or an unrecommended way of writing code. This is our small contract so far. So this should look pretty familiar as everything put together up until this point. We have our constants, our immutables, we have our state or stores, we have our fun function, we have our withdraw function, and everything else we put together up until this point. So let's pick up with some light reading. So before we move forward, there's one thing that we need to update. And that is the this expression here, which is 1 times 10 raised to the 18th. This is considered a magic number or a floating number. The reason we will be updating this number is because it can be kind of difficult to read for some users, and we really want to simplify things as much as we can when possible. Now, the general rule is that ideally, we want to use variables to describe what the number does, and we probably should use a variable for this expression, 1 times 10 raised to the 18th magic number we have in our contract. But instead of making this number a variable, we want to make it a constant. We can do that by doing this. So you can see we have precision, which is going to be a constant of type uint 256. We're going to set that equal to 1 times 10 raised to the 18th. Now notice that we're using the constant precision defined by its all capital letters, which will be an unsigned integer. Let's go down a little bit more. And lastly, notice that we will directly set this new constant equal to our magic number or our floating number. Note, remember, this number or this magic number, 1 times 10 raised to the 18th, is read as 1 times 10 raised to the 18th. And instead of dividing this floating number by our ETH amount times ETH price, we'll just say divide ETH amount times ETH price by precision. And we can do that because we set the precision variable, which is a constant of type UM 256, to the 1 times 10 raised to the 18th. So that's why we can just use the variable instead of using the whole expression. Now we're going to leave it there right now, and we are going to move forward tomorrow. Like I said, we are just starting this module, so I don't want to go too far, too fast. So we're going to pick it up tomorrow. But of course, I will keep you posted every step of the way. For now, this is the Python Poppy. You guys stay Gucci.